Hello, everyone. Congrats, you're on your second unit of distance learning. We're going to start talking about circles today. So first thing is the definition of a circle, which is a set of all points that are given distance from a given point. The center of a circle is the point in the middle of the circle. When we name a circle, we always name it by that center point, and we name it like this. Put a dot, a circle around it. And if I was naming this picture here, R is in the center, so I'd use an R here. And that symbol, this just means we're talking about a circle. Similar to when we talked about a triangle, we would put a little triangle in front of the letters. Here we're going to put this symbol in front of any letters. A radius is a segment with one endpoint at the center and one endpoint on the circle. So for example, Rx in this picture, that would be a radius because one point's on the circle, the other point is in the center. A radius is half of the diameter. A chord is a segment with both endpoints on the circle. So an example of a chord would be XY. A chord is across the whole thing. Another example of a chord could be AX. Okay, it does have two endpoints on the circle. A diameter is a chord that goes through the center. So XY could be a chord. It could also be a diameter because it does go through the center. It goes through R. Okay. Now we're going to name the circle. So if I was going to name this circle here, which we kind of already did, we'd put this symbol and then an R because that's in the center. If I'm going to name the radii, if I'm going to name the radii of the circle, I'm going to name all of the segments that look like they go through half of the diameter. So diameter would be XY. So I'm just going to put that down here for name a diameter. Diameter would be XY, which is this whole length. Another diameter could also be AB. Okay. It cuts through the centermost point of the circle. It also goes from endpoint to endpoint being on the circle. So any radii would be half of that. So RY could be one. RX could be another. RB could be another. And RA could be another. Naming the chords of the circle. There are a lot of chords here. So first of all, we do have our diameters that I said we can use again. Those are also chords. So we can say XY and AB. Another thing we could do here is AX and YB, because chords don't have to go through the center. It's just making sure those two endpoints are on the edge of the circle. Now let's put some numbers into this. If AB, this whole diameter, is 18, find AR. Well, remember a radius is half of the diameter, so this would be half of 18, which is 9. If RY, this piece of a diameter, which is a radius, is 10, find AR and AB. So both diameters should be the same, whether I'm talking about XY or AB. They should be the same. So these don't coincide, ENF. They're two different questions. So in this case, if RY is 10, that would also make this 10. It would also make this 10. It would also make this 10. Okay? Which means my diameters would be 20 because I'm doubling that radius. So AR is a radius, so AR would be 10. AB is a diameter, so AB would be 20. The next thing we got to do here is talk about circumference. The circumference is the distance around a circle. It's kind of like perimeter when we talk about other shapes. If a circle has a circumference of C units and a radius of R units, excuse me, then we can use two of these formulas, either C equals 2 pi r, and I would just always use this if you have the radius, because r stands for radius, and C equals d pi, d stands for diameter, so I would always choose between these two equations on whether they gave you the radius or the diameter. Okay, in these equations, C stands for circumference, R is radius, D is diameter, and pi is just a 3.14, and there's more numbers, and that is just literally a button in your calculator. Okay, should be on any online calculator as well. All right, I'm going to switch to my next page now, where I'm going to use circumference a little bit. So if I want to find the circumference of a circle with a radius of 6.8, that means, and I'm going to be using C equals 2 pi r instead of C equals d pi. Okay, those are my two formulas. C equals 2 pi r, C equals d pi. This one gave me a radius, so I'm probably going to use this one, C equals 2 pi r, because the radius r is in there. So find the circumference of a circle when the radius is 6.8. So I'm just going to plug in 6.8 here. I'm going to grab my calculator, and like always, there are plenty of online calculators you can use. I'm going to do 2 times, and put in parentheses my pi, times, parentheses, 6.8, and I get a circumference of 42.7. Okay. The next problem here, find the radius and the diameter of a circle. So they want me to find the radius and the diameter if they give me a circle with the circumference of 40. So I can use either of these equations because they want me to find both. I'm going to use this one just because there's less numbers and variables in it. So C equals d pi. So I know that C is 40, so I can plug that in. I'm solving here for d. Pi is just a number, it's not a variable, so I can divide by pi on both sides. So now in my calculator, I'm going to do parentheses 40 divided by parentheses pi. And I get that d is 12.7. And if I was going to find the radius, you should just know that radius equals half of the diameter, okay? Or diameter equals 2r. So they mean the same thing. So doubling the radius gets you the diameter. So cutting the diameter in half will get us the radius. So I'm just going to do 12.7 divided by 2, 6.35. I have now solved the problem because I have found my diameter and my radius. All right, these next two problems, crank it up a little bit. They want us to use the Pythagorean theorem and our knowledge of triangles. So there's a triangle within a circle in both of these. Find the exact circumference. This triangle has two sides congruent. That tells me that it is isosceles. That also just tells me that this is 9 and this is 9. So I can use the Pythagorean theorem to find the diameter. Okay. So a squared plus b squared plus c squared is my Pythagorean theorem. It's a right triangle. So I'm going to plug in, these are both my legs. I'm looking for my hypotenuse. So this will be 81 and 81. 81 plus 81 gives me 162. And now remember, when we're trying to solve here, we would take the square root of both sides. So I'm taking the square root of 162, and I would get approximately 12.7. And now that is actually my diameter. So I'm going to change that to a D just so it doesn't confuse you, because C also stands for circumference. So the diameter is 12.7. Now let's use our circumference formula. So C equals d pi to figure out what our circumference would be. So now I'm just going to plug in the d we found, which is 12.7, and multiply it by pi. So do 12.7 times pi. I get my circumference of, if I round it, it looks like it's about 40. We actually kind of went backwards from number 3. The numbers, interesting. Okay, last problem. We're going to use Pythagorean theorem again. You have this leg is 8, this leg is 6. Find the d, the diameter, which is our c when we're talking about Pythagorean theorem. So a squared plus b squared equals c squared. I'm going to plug in my 8 and my 6 for the legs. And I'm going to solve for, I'm going to call this d again so we don't get confused. This is our diameter. So I'm going to do 8 squared, which is 64, and 36. That gives me 100. The square root of 100 is 10. So my diameter here is 10. I am now going to plug that in because they want the circumference. So c equals d pi. I'm going to plug in 10 for d. 10 times pi gives me 31.4 as my circumference. Okay. Any questions with this, please make sure that you come on to my video call. I will be on from 11 to 12. All right. I hope everyone has a great day, and I hope that this new content isn't too challenging for you. Bye.